The Foundations of Geometry by David Hilbert.
Chapter 7. Geometrical Constructions Based upon the Axioms of Groups 1 through 5. Section 37. Analytical Representation of the Coordinates of Points, which can be so constructed. Besides the elementary geometrical problems considered in Section 36, there exists a long series of other problems whose solution is possible by the drawing of straight lines and the laying off of segments. In order to get a general survey of the scope of the problems which may be solved in this manner, let us take as the basis of our consideration a system of axes in rectangular coordinates and suppose that the coordinates of the points are, as usual, represented by real numbers or by functions of certain arbitrary parameters. In order to answer the question in respect to all the points capable of such a construction, we employ the following considerations. Let a system of definite points be given. Combine the coordinates of these points into a domain R. This domain contains, then, certain real numbers and certain arbitrary parameters P. Consider now the totality of points capable of construction by the drawing of straight lines and the laying off of definite segments. Making use of the system of points in question, we will call the domain formed from the coordinates of these points omega r, which will then contain real numbers and functions of the arbitrary parameters p. The discussion in section 17 shows that the drawing of straight lines and of parallels amounts analytically to the addition, subtraction, multiplication, and division of segments. Furthermore, the well-known formula given in section 9 for a rotation shows that the laying off of segments upon a straight line does not necessitate any other analytical operation than the extraction of the square root of the sum of the squares of two segments whose bases have been previously constructed. Conversely, in consequence of the Pythagorean theorem, we can always construct, by the aid of a right triangle, the square root of the sum of the squares of two segments by the mere laying off of segments. From these considerations, it follows that the domain omega r contains all of those and only those real numbers and functions of the parameters p, which arise from the numbers and parameters in R by means of a finite number of applications of the 5 operations, namely, the 4 elementary operations of arithmetic, and, in addition, the 5th operation of extracting the square root of the sum of two squares. We may express this result as follows. Theorem 41. A problem in geometrical construction is, then, possible of solution by drawing of straight lines and the laying off of segments, that is to say, by the use of the straight edge and a transfer of segments, when and only when, by the analytical solution of the problem, the coordinates of the desired points are such functions of the coordinates of the given points as may be determined by the rational operations, and in addition the extraction of the square root of the sum of two squares. From this proposition, we can at once show that not every problem which can be solved by the use of a compass can also be solved by the aid of a transfer of segments and a straight edge. For the purpose of showing this, let us consider again that geometry which was constructed in section 9 by the help of the domain omega of algebraic numbers. In this geometry, there exist only such segments as can be constructed by means of a straight edge and a transfer of segments, namely the segments determined by the numbers of the domain omega. Now, if omega is a number of the domain omega, we easily see from the definition of omega that every algebraic number conjugate to omega must lie also in omega. Since the numbers of the domain omega are evidently all real, it follows that it can contain only such real algebraic numbers as have their conjugates also real. Let us now consider the following problem, namely, to construct a right triangle having the hypotenuse 1 and one side the positive square root of 2 minus 1. The algebraic number, the square root of 2 times the positive square root of 2 minus 2, which expresses the numerical value of the other side, does not occur in the domain omega, since the conjugate number, the square root of minus 2 times the positive square root of 2 minus 2, is imaginary. This problem is, therefore, not capable of solution in the geometry in question, and hence cannot be constructed by means of a straight edge and a transfer of segments, although the solution by means of a compass is possible.
The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice: this ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Renholt. Programming and illustrations by Jim Renholt. 2019. Portrait of David Hilbert by Rita Ray Renholt. Thank you for listening.